Sikshayati, platform for eminent authors, engaging teachers, successful students. To know more, email
Standard deviation discrete series. Compute the standard deviation by following data using direct method, actual mean method and step deviation method. The value x is first row shows the value of x, the series, and the second row shows the respective frequency. So we create the table, first row showing the value of x, second the value of frequency, third column we get the value of x square, fourth column f into frequency into x square, and the fifth column is frequency into x. So sigma is equal to sigma fx square by n minus sigma fx by n square to the power half, means that is square root. So we have 17,700 by 60 minus 980 by 60 square, and the square root of the whole value, which comes to square root of 295 minus 16.33 square is equal to square root of 295 minus 266.67 is equal to square root of 28.33 is equal to 5.32 approximately. Next we compute the value as per actual, based on actual mean method. So we have again the table, x the values, f the frequency, fx is the frequency into the value as shown in the previous set of values. Then we get x is the deviation from the mean, x minus x bar. Here we first calculate the x bar mean, which is sigma fx by n is equal to 980 by 60, which is 15.6. so we get the value of x, that is deviation from the value 15.6. the next column shows the x square and the third column shows the fx square. So we have sigma is equal to square root of sigma fx square by n is equal to sigma square root of 17.50 is 1725.60 by 60 is equal to square root of 28.76 is equal to 5.36 approximately. Now we compute the standard deviation from assumed mean method. So here the assumed mean, we assume the value of a is 15. So again the first column shows the value of x, second is the frequency, 3 the deviation from the assumed mean, that is 15. So that column shows the deviation from 15. The next column shows the d square, the next column shows the value of f into d square, and the next column fd. So putting the value in the formula, we get sigma is equal to fd square by n minus sigma fd by n square, the whole thing to the power half, that is square root. So is equal to square root of 1800 by 60 by minus 80 by 60 square, so square root of 30 minus 1.78, that we get square root of 28.22 is equal to 5.31 approximately. Next we compute the value with from step deviation method. In this also we assume a value of a is equal to 15, that is the assumed value. So we create the table in the same manner as above. Here x, the first column, second column, third column remains same. D, we now compute the value of d dash, assuming a scale of c is equal to 50. So we get the d dash square, fd dash square, and fd dash by computing from the respective values. So here sigma is equal to sigma fd square by n minus sigma fd dash by n square, the whole thing to the power half, that is to make the square root, into c, that is the factor, is equal to sigma 70 is equal to square root of the expression 72 by 16 minus 16 by 60 60 whole square multiplied by the value 5, the scale factor is equal to square root of 1.2 minus 0.71 into 5 is equal to square root of 1.129 into 5 is equal to 1.062 into 5 is equal to 5.31 approximately. So you get the values as approximately same by the different methods.
Thank you for watching the video. Kindly write your comments. Click on the red subscribe button at the bottom of the video to get more details and free ebook. Email us.